Well, good morning, everybody. And thank you for joining our webinar this morning on the new leaner, cleaner, and meaner Ford 7.3 Godzilla engine. Today, I'm Robert Holt, Director of Sales here at Rush Bus Centers. Joining me today will be Ryan Zick, the VP of Sales at Roush CleanTech, Tom Hopkins, Business Development Manager at Roush CleanTech, KAYLA Pitts with the Regional Sales Manager from Bluebird Corporation, and Tim Gordon, the Regional Executive Director for Bluebird Corporation as well. Today we're going to cover a number of topics, and the biggest one being the Roush 7.3 Godzilla engine introduction into the Vision model, Bluebird. And Tom Hopkins and Ryan Zick will cover the product development process, the emission profile of the new engine, the engine comparison with the 7.3 versus the 6.8, and benefits of gasoline and propane inside your fleets today. Then KAYLA and Tim will talk about the new grille design on the Bluebird Vision, the center routing updates that were required for the engine installation, and then they'll talk to you about the Mobileye collision mitigation system as well. Then I'll come back to you at the end, and we'll talk about some of the customer enhancements we've made here at Rush since integrating our bus centers inside of our existing dealerships here in the state of Texas. And then we'll open it up for questions at the end. So with that, I will turn it over to Tom Hopkins and Ryan Zick with Roush.
Thanks, Robert. I think Tom's having some connectivity issues, so we'll wait for him to come back online here. But I was just going to ask you, is the screen displaying, and are you seeing the full presentation or the presenter view?
Full presentation.
You're in the full presentation?
Yep. Yes.
Wonderful. And Tom, are you back on?
I'm back.
Perfect. Okay. Well, I'll hand it over to you, Mr. Hopkins, if you're ready.
Thank you, Ryan and Robert. Appreciate the opportunity to speak with you all today in the great state of Texas. We're going to talk a little bit about the Spark Ignited offering and our partnership with Bluebird, a partnership that began way back in 2012. So we're coming up on close to a decade of working together with Bluebird on this diesel alternative product offering. And today we're going to focus a little bit more on the new powertrain package and the updates from the chassis side at Bluebird. But we're also going to mix in a little bit of the benefits of why you should choose the diesel alternative with the Bluebird Vision gasoline or propane bus. So Ryan, next. So we recognize that districts, when they have a consideration to make a change or purchase a bus, they have many fuel options today, from diesel to gasoline to propane to CNG and electric. And although CNGs become less of a player in the market, we do still see some activity in the CNG space. But when you consider all of the things that go along with making a bus decision, a purchasing decision for an alternative fuel, like ease of adoption, energy independence, or emissions, cost of ownership, range, scalability, maintenance, we still feel strongly that we can paint a really great picture of why propane checks every single one of those boxes as a preferred fuel. Gasoline is not far behind, checks many of those boxes when you talk about operational simplicity, ease of maintenance, and a little bit of fuel savings versus diesel, not to mention the cost of acquisition is a little bit less than a diesel bus as well. So we're going to talk a little bit about these things today as we move through the presentation. Next. First, I just wanted to talk about our progress. Today, we have over 37,000 vehicles on the road today, commercial fleets and school bus. We transport over 1 billion students to school. We've accumulated over 1 billion miles on our products, and we transport over 1.2 million of students to school every day. And we're currently active in over 2,500 fleets across the country and Canada. Just to show you what that looks like with Bluebird, this is our map of our propane and gasoline deployments throughout the US and Canada. You can see that we've actually deployed in Alaska, and we are in all 50 states with this product and every province in Canada today. So we're pretty excited about the continued adoption of the diesel alternative products with the Bluebird Vision powered by Ford and Roush. Talk about Texas specifically, running this powertrain package or the previous powertrain package. We've deployed over 1,100 vehicles, 1,100 school bus vehicles powered by propane at over 38 school districts, and 871 gasoline school buses at 132 school districts across the state of Texas. I mentioned the partnership going back to 2012. When you look at disruptive growth in the market, since that time frame, you can see Our first year partnered with Bluebird, we were about 9% of their production volume. And you can see some pretty steady growth from 2014, 2016, 2018. Where 2019, we actually came very close to eclipsing the 50% mark in terms of production output at Bluebird's factory in Fort Valley, Georgia. And then last year, 2020, even though it was a little bit of a down year considering the pandemic, the diesel alternatives, gasoline, propane, electric, and CNG, actually made up more than 50% of Bluebird's total production volume for the year. At 54%, that's pretty remarkable in just about an 8-year time span. So I'm going to hand it back over to Ryan to talk about the product development process and how we integrate this new Godzilla 7.3 liter package into the Vision school bus. Ryan?
Thanks, Tom. So as Tom said, we really wanted to share some information with all of you today on the journey that we've been on. And when I say we, Roush, Bluebird, Ford, to pull together this new powertrain into the Bluebird Vision school bus. So it's really been a long time in development. There's a lot that goes into it. So we thought we'd give you a peek behind the scenes of some of the things that we go through to launch a big powertrain program like that. So from a high level, we'll talk about the product development process, how that works in general. We'll get into some of the product information on the engine, the details of it, compare it to the outgoing 6.8 liter, and then also share some details with you on the launch timing. So if we look at a program in general, and this is whether we're talking about a small update or a major one, like a new powertrain going into a school bus, these are some of the basic milestones that you hit along the way. Starting there with the business development phase, right? This is where we identify, what's the task at hand? In this case, we're trying to switch over to the latest and greatest technology available from Ford Motor Company, right? The 7.3 liter. So we knew what the task was. Let's integrate the 7.3 liter into the Bluebird Vision school bus. So that was the task that we had to do. So then we get into this product design phase, right? What does the engine look like? What are the dimensions? What configurations do our customer needs? What are the needs, right? Some run air brakes, so we need an air compressor. Some need air conditioning, so we need to accommodate for that. We have to integrate it with the transmission, with the overall architecture of the vehicle. So a lot goes into that. That's where a lot of your computer-aided design comes in. And then we get into product validation phase, where we're actually going to use hard parts, materials, engines, vehicles to do some testing, make sure we've got a good product. And then once we have all of that confirmed and validated, we get into the product launch phase, where we're actually going to have the vehicle hitting the marketplace, which is really where we're at today and why we're having this presentation. And then we get into this continuous improvement phase. And that's one that's very important, usually overlooked, but that's where we continually look at the product we have there in the field, and we make those minor updates, changes, improvements, so that we continually can offer the best offering that's out there for a powertrain in a school bus. So going on to a little bit more detail of the timeline. So today we sit April 1st, 2021, but I want you to back up, if you wouldn't mind, all the way to March of 2018. So about 3 years ago, that's when this program kicked off. So it's been a long time in process and development, and that's really required, all that due diligence between then and now is all the work that went in to make sure that this is going to be a successful launch, a successful program, and that we have ironed out all the details as it goes through of putting a powertrain into a Bluebird Vision school bus. So March 2018, we kicked the program off. That summer, we really got into the analytical evaluation of it. That's really where we're talking about that computer-aided design. So that's where we're taking all those different configurations along with the design of the new engine. We're putting them all together, and then we're packaging them electronically into the bus. We're making sure that we don't have any contact issues, right? The hood can still close. It fits between the frame rails. We're mapping all that out. And then on the backside, we're also mapping out the software piece of it, right? How are we going to control it? What type of software do we need to control the vehicle and the integration with the body control modules and all those other things that come into play when you start talking about the complete vehicle? So moving on a little bit further down the development timeline, we get into October and late, that fall of 18 and into the winter of 19. And we're talking about prototype part development and mule engine development. So a mule engine is really that prototype level engine that goes into a vehicle, right? So we start out, and this is one of Roush's specialties, where we start doing dyno work. So this would be engine dynamometer testing, and you're looking right there into one of our cells at our building 1 in Livonia, Michigan, where we do a ton of this work for, not only Bluebird, but Ford, GM, Chrysler, a bunch of automotive and on-highway people, because this is a great way to understand where you might have reliability issues, durability issues. So the engine that you're looking at there that has, looks like about 1 million wires and sensors coming out of it, because we want to know everything, right? Temperatures, pressures, anything we can find out about that and glean, we were going to take from that dynamometer testing. And no exaggeration, this engine that you're looking at there is a 734 Bluebird Vision school bus application. And that engine by itself went through hundreds of hours, no exaggeration, of engine dynamometer testing. So to give you an example of that, base engine went through, and then we'd put on the front end accessory drive, all those different configurations we mentioned, hydraulic brake, air condition, no air condition, with and without a transmission, with and without the factory exhaust system, on and on, to make sure we prove out and validate each and every configuration that we have there. And hopefully we'll be able to share, I'm going to try to share a video just behind the scenes of what that dyno looks like. So I'm not sure if you all had audio come through on that or not, but I just wanted to show, and we could share that video with you too if you'd like to see it, but just a sample of what some of those engines go through. And in this case, the 7.3 liter for the Bluebird school bus, but they really get torture tested. You could hopefully see on that video how red the manifolds get and how they're held there. We actually tested that engine well beyond the RPM maximum thresholds that we'll have in the Bluebird school bus by almost 2,000 RPM above our maximum threshold in school bus. So torture tested, put through what we call thermal aging, where we cool the engine down and then heat it right back up. We want to see that expansion and contraction of parts within the engine, all those different metals moving differently. That's where we're going to find out about possible wear concerns, possible weak points. So really cool stuff, and really a lot of due diligence done by our engineering team to make sure that we've got a good engine and package, the calibration, everything that goes along with it, right down to tailpipe emissions testing, all happens in those dynamometer labs. So moving on to the a little bit further on the timeline there. So if we get into the late winter and spring of 2019, that's where we got into prototype engine builds. And then we get into the summer of 19, and that's where we get into some of the really fun stuff, which is prototype vehicle builds. So all the way back in July of 19, Bluebird was building school buses with the 7.3 liter in it for the purposes of further testing. So not only do we want to prove it out in a dynamometer lab and obviously on the computer-aided design, all the CAD work, but we also want to put these in vehicles and do all sorts of durability testing to make sure that we have a complete package that works all together as one. And to show you behind the scenes too of what we do with some of that testing. So if we get into, it was basically August through the winter, 19 into 20 is when we did a lot of this testing. And this is another specialty of Roush. So all of the different facilities that you see here, of course, we have our headquarters in Michigan, but we have a lot of different vehicle testing centers throughout the United States. And for this application for Bluebird and the Roush commercial products that we offer, we did testing in Bemidji, Minnesota. So that is where we do cold weather testing, obviously. And at one time, not that long ago, I'd say not that applicable to Texas, but I can't really say that anymore. It definitely gets cold in Texas. We learned that. So Bemidji, Minnesota, we want to understand, how does this vehicle perform in well below sub-zero temperatures, right? Negative 40 degrees Fahrenheit. How does the fuel system act? How does the powertrain act? How does it all come together? If you move over to Colorado, We have high altitude testing there. So this is where we get to simulate the most extreme grades that we could put the vehicle on, as well as 5,000 to 8,000 feet of altitude. So how does the vehicle perform in that low oxygen environment, thin atmosphere? You move over to Las Vegas, Nevada, and also into Northern Arizona is where we have the test run. And that's where we're going to do hot, dry testing. So how do the vehicles perform in extreme heat? And then we also have some grades out there that we could run the vehicles on. So looking at some of our test vehicles here, these are 3 of 8 that we had out on these test runs that we ran through that fall through winter that we just mentioned. So you can see there an F750, which is a Roush application. You could see one of the Bluebird Visions that we had out there. That was one of 4 of the Visions that we had out there, different sizes, different rear axle ratios, different fuel types. We wanted to test, as we could say, every configuration we had available. Then you can see an E-Series commercial vehicle next to it. And what's really interesting is if you look at the back of that F750, we don't run these vehicles empty. That's actually a crane counterweight that's sitting on the back of that F750. And we did the same thing to the Bluebird school bus, but it was hard to get the crane counterweight in. So we use these agricultural totes that we fill up with water. In this case, we have a I-beam structure in the floor of the vehicle so we could secure those loads. And then we have that vehicle maxed out to its max gross vehicle weight rating. So for the buses that we had on this trip, that was between 26,000 and 33,000 pounds that we had these vehicles rated to. So complete worst case scenario, right? With school children, it's really hard to get to a vehicle's max GVWR, but we want to do it for the purposes of testing. So we want to know at full weight capacity, at 115 degrees ambient temperature and pulling hills all day, what is that vehicle going to do? Are we going to have success with it? Are we going to have any issues? So really fun durability testing that we get to do there. And that's very similar whether we're talking about the cold weather applications, the high altitude, or the heat. So going on a step further, we get to more recent times here. So October 2020, we're building production intent pilot engines. And really the purpose behind going through a pilot build, right, before you go to full scale, turn the switch on, everything is full go, is we want to do those final tests. We want to know that our assembly process is correct. We want to know that our quality checks are correct. We want to prove out our manufacturing line. So we go through a pilot build phase that really helps us prime up before we go live, and we can iron out any final details before everything goes to full 7.3. So this was still in the time we were building 6.8 liters. We were going through our pilot engine build with Bluebird. So that really leads us to the engine itself and where we've gotten to and what we have to offer today. So the 7.3 liter engine in the Bluebird school bus. And we really use these 3 identifiers here of cleaner, meaner, and leaner, really talking about how this engine stacks up against the competition and also how it stacks up against the outgoing 6.8 liter V10. But the whole goal of this engine was to make improvements in all these key areas, right? We wanted to have more power, but we wanted to have more efficiency. And we also wanted to meet, even further out tailpipe emission standards. And we wanted to do that by having a really strong and durable design. So I think Ford did a great job of meeting all of these different criteria, and it carries through into the Bluebird school bus. So if we look at the base engine, we talk about that meaner piece, and we have more power in this engine than we do with the outgoing V10, and it also is the highest horsepower available in the class and school bus. So we look at the outgoing V10 at about 320 horse, other competitors in the same space around 270 horsepower, and the 7.3 liter comes in at 350 horsepower. And it does that at actually a lower RPM than what the V10 was able to do, so at 3,900 RPM. And if you remember, I mentioned that we really pushed this engine beyond that capability when we did dynamometer testing. So we were running the engine at 6,000 RPMs when we did our testing, and we're limiting the engine to 3,900 in the Bluebird application, still making 350 horsepower and plenty of torque, 468 at that same mark. Idle is still at 680, so still the same idle RPM that we had with the outgoing V10. And then you have a limited max of 4,050. So going down to the design of the engine, it is a pushrod 2-valve style V8. It equates out to about 445 cubic inch. And then the compression ratio, and this is where some of our efficiency comes in, we bumped it up to 10.5 to 1. Really beneficial for us from an efficiency standpoint. It lets us take advantage of some of the octane that we get naturally in propane. Propane has about 108 octane naturally, so bumping it up to 10.5 to 1 has really let us push the envelope with that fuel. Not only is it a big improvement from V10, which was at 9.2 to 1, it's also class leading, so highest compression ratio in the internal combustion spark ignited class in school bus at 10.5 to 1. Now, if we look at the overall design of the engine, really, we've had some really big improvements, I think, from a durability standpoint, from a robustness standpoint, from a serviceability standpoint that I think a lot of you are really going to like. So we went from that overhead cam design that we had in the V10 to a cam in block with a variable cam phaser, but a very simple fault off system. So if there is any type of failure on that cam system, it's meant to basically continue to run in full power mode. So no long-term concerns there. And I think the feedback that Ford got from this engine when they talked to their big fleet users, and mega fleet users, right? Like UPS and FedEx and people that buy thousands and thousands of these engines for their medium duty trucks, was that they didn't want more complexity. They didn't want tougher things to work on. They wanted simple, robust, efficient, and powerful. And I think that's what we're seeing the 7.3 liter deliver here. So we look at all those things like the cam in block. We look at the 2-valve push rod style. We look at the oil piston cooling jackets that were put in, the thicker sleeves between the cylinders. All of those different things really lead to those robustness enhancements. In addition to that, Ford went to a 6-bolt design on the lower end on the crankshaft, which makes it the only one, in the industry, in this segment that has a 6-bolt design. So really good robustness on the bottom end of the engine. And then we look at also the scale of it, which is really unique to the 7.3 liter. Nothing else really in the school bus segment for spark ignited is going to be able to offer this. This is the wide scale that it's used in the Ford applications, and also Ford chassis with a lot of different vocations here. So you can see everything from that beautiful Bluebird school bus down there at the bottom to the Roush F250 you can see up there at the top, but dump trucks, tow trucks, the RV industry, step vans, which are like, the box trucks that deliver all those Amazon deliveries to our houses just about every day, refrigeration trucks, all of those different vehicles are heavily underpinned by the 7.3 liter. So what that means to you as an end user is that long-term parts, support, technical publications, experience are going to go hand in hand with the 7.3 liter engine in the school bus. So really, really good commonality there. And you may also have this engine being implemented in other parts of your fleet already, whether you're talking about an F550 service vehicle on through to some other applications that get used for, food service, landscape, and other things in school districts. But in talking to the engine plant at Ford today, they're not quite at full ramp, and they're already making a little bit over 600 of these engines per day for all the different applications that you could see here. So you could already kind of see how much impact this is going to have on the medium duty market. So it's already going to be the #1 medium duty spark ignited engine in class 4 through 7. So moving on to the Gen 5 fuel system, which is what we're calling this latest iteration, the 7.3 liter in the Bluebird school bus. It's going to be offered in both propane and gasoline. Formerly, the V10 was offered in compressed natural gas. Compressed natural gas will not be an offering for the 7.3 liter, so it will be propane and gasoline only. But the good news is that across the board, if you've ordered with us in the past, if you have a 6.8 liter in your fleet, whether we're talking about propane or whether we're talking about gasoline, all the same configurations are available. So whether you had our extended range tank standard, or even the smaller tank that we used on the 19-foot 10-inch body in the Bluebird application, also the Microbird, if you had power shift or econo shift, and also any of our optional low NOx offerings, that is still fully available. On the gasoline side, 100-gallon and 60-gallon tanks, all of those different configurations, rear axle ratio choices, body choices, brake choices, everything is fully available from the 7.3 liter to be identical to that. A few other improvements that I'd like to talk about, maybe not as big as the engine itself, but definitely big improvements. We have a refined front end accessory drive. So with the outgoing V10, we had up to 3 belts that were on the front of the engine to drive all the different components, air brake, air conditioning compressors, power steering pumps, alternators, all that good stuff. On the 7.3 liter, we'll only have a maximum of 2. We were also able to eliminate some of the bracketry that we had that was associated with the V10 and really just overall refine the front end accessory drive. Once again, the whole goal here was make it simpler, more robust, and easier to service. So I think we met that goal across the board from the core engine itself all the way through to the accessories that go on the engine, depending on your configuration. Here's an image of the fuel systems compared side by side. So on the left here, you have the 7.3 liter, and on the right, you have the 6.8 liter V10. So our team also on the fuel system routing went through a pretty heavy exercise of bracketry, retention, streamlining, trying to keep all the components even more refined than what we had on the outgoing V10, retained closer to the block and easier once again to service, and also out of the way for other components to be. So all those different configurations and components that you might add onto the front end of the engine. So this is really where we talk about the cleaner side of it. So obviously, every year, every couple years, emission standards from the tailpipe get stricter. Constantly, we're looking at these 8 different constituents at the tailpipe. So, you see on here NOx, HCHO, particulate matter, on down to the greenhouse gas family. Every couple of years, right, we focus on reducing one of those. And when I say we, the EPA and California Air Resource Board, focuses on the reduction of these. And we've really seen the focus here lately shift for what 2023 coming and then 2027 after that is reducing NOx down. So the federal standard today on NOx is 0.2. And as you can see here, the 7.3 liter comes at 0.021. So like I said, on federal 0.2, so we're about 90% lower than what the federal requirement is today. So as you can see, the 7.3 liter out of the box is really built with the future emission standards in mind. And we're not going to have any major changes going from the products we're launching and starting with today to the standards that are coming around the corner. And Tom's going to share with you in a little bit some of the things that diesel is going to have to look at, because there are some things that they're pretty close to the threshold on today that major changes will have to happen on the exhaust emission system to be able to meet those future standards. But we're in a really great spot to offer you something that's not going to have change forecasted for a long time from this point forward with this 7.3 liter. And if you look at it overall, 70% cleaner across all those things than the federal standards. So considerably lower. Just a quick comparison now between the outgoing 6.8 liter V10 to the new 7.3 liter V8. Looking at those in a side-by-side, that 6.8 liter, it was originally designed in 1997. That's when it launched. So it's been a great engine for us for a really long time. And it's really, we've capitalized on the things we've learned from it, and we've incorporated that into the 7.3 liter. So dimensionally, if you look at these two, and these are dimensionally accurate drawings of these two engines side by side, you can see it's kind of interesting, right? We went up in displacement on the 7.3 liter, right, from the 6.8. So we're up in cylinder size, but we've actually decreased the outer measurements of the engine. So our height's gone from 915 millimeters down to 835. Our width has come in from 837 to 757. Our length's about the same, just a touch longer, and then our weight's down a little bit. So this is really that leaner side of the engine comparison. So because we went to a cam in block, took out the overhead cam, went to a 2-valve design, a lot of things in the design of the engine has allowed it to be more powerful, more displacement, but more compact and overall lighter. So all of those things add up to better serviceability, reduced weight carrying of the vehicle, which plays into greenhouse gases for the total vehicle emissions. And also, just the importance of being able to access everything, that serviceability when you need to get access to something, the more condensed engine really pays off for the technicians. And then a service and parts comparison. So when we look at the outgoing V10 versus the incoming 7.3 liter, the big takeaway is that more is staying the same from the service and parts comparison than's changing. So really we look at, from an oil change standpoint, other than the quarts, which is going from 7 to 8 quarts, the interval, the oil filter, the oil type all stays the same. So great news, if you have the V10 in your fleet now, what you're using for that works for the 7.3 liter. The spark plug interval stays the same. The plug itself does change. And then the transmission that we use stays the same. Also, diagnostic tools and software, things that you're using today, stays the same. So anybody that's using the 6.8 liter currently in their fleet, I think it's going to be a welcome change to the 7.3 liter in that a lot of it's going to be familiar. One other comparison that we'd like to look at here, this goes along with the robustness enhancements, you know, whether we're talking about the 6-bolt main or the cam and block design. One of the things we learned from the 6.8 liter is that, you know, the exhaust manifold studs can never be too large. So Ford went from an M8 stud that you can see there on the left-hand drawing or the left-hand CAD image to an M10 bolt on the 7.3 liter. So you can see either the real pictures compared to a number 2 pencil, the best reference point that I had that I think everybody's familiar with. And then just the stud drawings, you can see a considerably larger stud used for the 7.3 liter V8. You know, these manifolds have a lot of tension on them when you're talking about a commercial vehicle that has a very large exhaust system. So, and a lot of, you know, temperature changes in different corrosive environments. So the larger the stud, the better. And we saw Ford really step that up on the 7.3 liter. So that really takes us to where we are today, and that's product launch phase. And that's really the point at which both Roush and Bluebird at today. So this point forward, it is 7.3 liter in the Bluebird Vision product. So with that, I'll hand it back over to Tom Hopkins to walk you through a little bit more about the current landscape with propane and gasoline and where we're headed with diesel.
Thanks, Ryan. Great presentation so far. I'm going to talk a little bit about the buyer motivators. When we talk to school districts or customers, we typically get feedback that their concerns fall in one of these 4 buckets. Energy independence, can I control my fuel cost? Is it stable? Is it difficult to change to? Duty cycle simplification. You know, most school districts today that we speak with are still dealing with major headaches from the diesel emission side. So can I simplify that for my shop, my technicians, and save us some money? The environmental piece, which Ryan touched on briefly with the new emissions profile from the 7.3 liter engine. And of course, the financial piece, it has to make sense financially. You can't just make a good change like this without it being, without having a big impact on the bottom line. So start with fuel trends. When we look at the landscape of fuel pricing today, this just goes back to September 7th of 2020 there on the upper left. You see where we were down around $2 or $2.50 for gas or diesel. And you see a steady climb up over to $3 a gallon today with diesel pricing. I looked at the latest EAI report, and it was actually coming in at $3.19 a gallon as a US average. Gasoline not far behind in a $2.79, $2.85 range. And then there on the right, you look at that upper right, just the last 30 days, February to through March, crude oil pricing. You see these really significant rises, followed by some moderate dips, but the story here is that it's continuing to rise at a pretty accelerated rate. And those 2 charts that you see there in the upper side tell a really good story together. Conversely, when you look at propane, school districts that are looking at their propane pricing, existing users that are looking at putting their fuel out to bid, or new customers that are considering adding a new refueling station for moving to propane, they typically have a really big advantage when propane providers generally price out fuel systems. They're looking at it in the context of a term. I want your fuel price locked in for a 1, 2, or 3 year term now we're seeing. So when fuel providers look at how they're going to price your fuel, they'll generally look at the futures. And on the bottom there, you see a map of the propane future pricing and what it is predicted to do over the next 4 years, actually. So you see a pretty steady drop. We have a very robust supply. We have pretty steady demand. The United States is still a net exporter of propane. So we're actually exporting more than we're consuming today. And 97% of the propane that is produced here in North America. So we've got a really robust supply chain for it. Ryan touched on this a little bit when he was going through the advantages of 7.3, but you do have duty cycle simplification or simplicity with your propane fleet, your gasoline fleet, and your white fleet. Running the same powertrain package, you saw that breadth of applications that Ford is producing the 7.3 liter engine for, commonality with fluids, spark plugs, diagnostic software, replacement parts, where your long-term replacement parts are coming from. I know some folks use the local Napas or auto parts store or places like rockauto.com, have a very robust supply chain of replacement parts in these commonly used high volume OEM medium duty applications. And then of course, I'd be remiss if I didn't point out that Blue Bird has the best in the business 5-year unlimited mile warranty that supports the Blue Bird gasoline or propane vision with an option for a 7-year plan as well on that powertrain and fuel system. Preventative maintenance piece, 8 quarts of oil and a simple $4 spin on oil filter versus anywhere from 17 to 30 quarts on the diesel with 1 to 2 very expensive filters, typically $18 to $28 in that range for the diesel fuel price. And we've got a chart that shows the comparison side by side. When you look at worst case scenario on the 7.3 liter oil change, considering the power steering element filter in this model, you're looking at about a $75 turn for an oil change in that scenario. Compared to the Cummins ISB 6.7, all in, you're looking at $277 a turn. Now you may change the oil more frequently at 5,000 mile intervals versus perhaps a 10,000 with diesel, but you're still gonna save very close to $200 for each PM when you look at it side by side. I think there's a little bubble that calls out Ryan. And then the diesel, as we know it today, you've got all these added components that make diesel buses compliant to today's standards. Your charged air coolers, your turbochargers, your DEF heads, your DEF tanks, your SCR catalyst, all your NOx sensors that go into it, all very big headaches for school districts that are running diesel today in that low speed stop-start duty cycle. And all of that translates to cost. When you look at changing out each of these components just one time post-warranty in a 15-year vehicle life cycle, it's over $21,000 of expense. And you won't find any of these on the propane-powered or gasoline-powered Blue Bird Vision with the 7.3 liter Godzilla. And then Ryan touched on diesel emission standards and how the changes affect how OEMs have to react to those changes. And in 2024, there's additional changes coming down that are going to mandate 0.05 NOx for diesel emissions. And in 2027, another step down to 0.02 NOx. And when you look at the two illustrations there on the right, this comes from Cummins' website. You look at the two illustrations there in the center on the right, they're basically indicating that it appears they're looking to add additional hardware to keep up with these increasingly stringent emission standards. And then I think Ryan mentioned that we've got a product today that will keep you compliant to that 0.02 level of NOx through that 2027 change with no need to add any additional hardware or complexity to your fuel system to make it compliant with the emission standards. One other thing of note, I just want to point out, Brian, I don't know if you can back up or not, but some of you may have seen, I know Thomas Built Bus had put out this really big marketing push a few years back in 2016 to 2018 to promote their latest and greatest DD5 and how it was going to change the world and revolutionize student transportation with their extended PMs and longevity that they believe that they had with that engine. And there was a notice that came out in heavy duty trucking about 4 weeks ago that indicated that they were actually moving away from that powertrain platform in 2024. They've announced a new partnership with Cummins and Daimler that's going to drive their next generation of powertrain for the medium duty class vehicles, which is really interesting considering they went from one extreme to the other in just about an 8-year shelf life. Next, Ryan. So when you look at those Ford engine components on the 7.3 liter V8 and how they stack up against the diesel emission components, these are the items that you might consider post-warranty on the Blue Bird Vision, either gasoline or propane. This example is showing you the propane example, mainly because the cost of the fuel injectors is slightly higher. But all in, if you were to change all of these components one time post-warranty, you're looking about almost $3,000, which is just a fraction of what those diesel emission components cost. Now that's considering you have to change each of them. The great thing about the propane powered Vision and the fuel injectors is that those injectors are serviceable individually. It takes about 15 minutes to change one out. So you don't have to change out a whole fuel rail when you have an injector go bad in that scenario. It's just one quick change. And then should you have a catastrophic engine failure, the engine replacement cost is significantly lower as well. It actually comes in at about half the cost of the competition. And this is with early pricing out of Ford, considering their production volumes just ramping up. So we expect that this pricing may improve slightly over time. But considering the Cummins ISB at almost $19,000 and that PSI 8.8 at $21,000, that's substantial savings when you look at the potential for a catastrophic failure. And then we have this PSI engine quote that a customer shared with us that just bears out that $20,000 plus replacement cost for that PSI engine. Lower volume, harder to produce, not as robust aftermarket channel, all makes that pricing a little bit more tight to bring down. And then we want to talk a little bit about the TCO model. So when you transition to a new fuel, you want to be able to identify where is it going to save me money. This is a version that's dated by a few weeks. I just updated one the other day with the latest EIA pricing. But in this example, you see with the propane fuel at $1 per gallon, diesel at $2.99 a gallon, gasoline at $2.79. Our fuel economy adjusted for energy content, diesel at 8 miles per gallon, propane at 6, or propane at 4.5, and gasoline at 6. In this example, this operator is going to use their bus for 15 years and run approximately 15,000 miles per year. And then we've got our estimated pricing call outs there. This may not be exactly apples to apples, but what you see in Texas, but I think the delta between the fuels and the bus is pretty comparable or pretty static across the country. So I think the gap is what we're looking to measure more than just the actual pricing that's there. And then when you consider the total cost of ownership in this model, just using your basic PM model, your oil changes, your DEF fluid, and your fuel filter changes, you can see that your diesel pricing comes in using diesel as a baseline at about 81 cents per mile. Gasoline is slightly higher at 86, but again, I think when you see the adjusted pricing of what we're looking at today, that narrows a little bit closer to about a penny delta between those two fuels. Gasoline also has that lower cost of ownership up front. Propane with no incentives comes in at 67 cents per mile. And that translates to about a $29,000 lifetime savings versus that diesel bus, mainly because you have less maintenance, you have less cost of maintenance, and you have less cost on your fuel. When you consider that today, the federal government is still offering a federal tax credit at 36 cents per gallon for every gallon of fuel that you dispense out of your own refueling station. That second column there shows what that rebate means, and it accelerates your savings to over $47,000 for the life of that vehicle and takes your cost per mile down to 59 cents. Now that's a tax credit that's been available every year since 2010, and there's current push right now in Congress to have that extended out an additional 4 years. So it's pretty excited to see that they may be coming back. There's no guarantee that it'll be around forever, but we wanted to show both examples that one, propane can stand alone on its own without any kind of rebates. But when you do have the rebates, it just sweetens the pot that much more and makes the case for propane a whole lot easier. Okay. And then one more slide on the environment. I think Ryan pointed out the emissions profile. This is a study that was done in Georgia in 2019. Georgia State University conducted this with over 2,000 bus riders. They compared the performance of students that rode low emission school buses, like the ones powered by propane, compared to older diesel emissions buses. And what they found was that the students who rode in the school buses, the alternative fuel school buses with lower emission profiles, had higher test scores in math and English than their counterparts that rode in those diesel school buses with the higher emission profile. The study also found that those same students that had the higher test scores from the lower emission school buses also had better attendance than their counterparts that rode in the diesel school buses. And when you look at the emissions profiles today and how aggressive they're getting, and the need to add additional hardware, I think it's going to become more and more, this type of information is going to become more and more prevalent for school districts to make decisions. You combine this with the PERC study from a few years ago that compared the in-use operation. That's another great thing, is that, you know, the diesel emissions profiles are set up in a controlled study, not really in use or on road. When you look at the on-road application, or you put a diesel bus and a propane bus side by side, let them run through their route cycles, like PERC did back in, I think it was 2018, we found that the propane bus actually was 90% cleaner than the diesel school bus. So all of these new studies are coming out that are great, that really continue to point that, you know, lower emission school buses like propane are really the way to go. I think with that, I'll turn it over to KAYLA, who's going to talk about the chassis changes at Bluebird. And KAYLA, take it away.
Hey, Ryan or Tom, KAYLA's having some difficulties with the audio. So Tim, are you on?
Yeah, I see you're connecting now.
Robert, do you want to try to run through the updates?
Yeah, let's just run through them real quick.
Okay, and then maybe KAYLA will come on. She'll connect audio while we're going. So yeah, these are the updates.
Can you guys hear me?
Oh,
Yes.
Yeah, we got you now.
You can?
Yes.
Perfect. Sorry about that. I'm having issues this morning. One thing I did want to mention before the Bluebird product updates, we actually launched production of the 7.3 liter gas on March 1st. Since then, we have a backlog of 834 gas units. We'll be launching production of the 7.3 liter propane today, actually on April 1st. And currently we have a backlog of 273 units for propane. So there's a lot of activity in the market. We're excited about the product, excited to be on this call with you guys, and thanks Roush for the great presentation. All right, you can go to the next slide. All right, first we have a new updated front grille, sleek design. It'll be available in both our standard silver with a black grille, as well as the option of yellow surrounding grille. Next. All right, so we're currently prototyping a simplified center routing system for wiring air and fuel lines throughout the bus, making maintenance easier for technicians. All the major wires, air and fuel lines will be routed through the center of the chassis with revised cross members, eliminating the possibility of rubs and chafes. This new routing will improve serviceability and the overall durability of our conventional bus. Next slide. All right, Mobileye. Bluebird is proud to introduce the Mobileye Collision Mitigation Safety Edition system, which is now offered as a factory installed option. This advanced system scans the roadway for obstacles to help drivers avoid potential dangers. Similar to passenger vehicles, the Mobileye Collision Avoidance sends a series of audible and visual alerts that help reduce the risk of collisions by deterring bad behaviors such as distracted driving through a series of visual and audio cues. While other systems like Index Wingman may take control of the vehicle in certain situations, Mobileye's collisions avoidance system gives full control to the driver. We've seen that it's proven to be greatly reduce collision when properly used. Next slide. This is kind of a recap. A few of the key features included in this system are forward collision warning, lane departure warning, pedestrian cyclist warning, headway monitoring warnings, and also a speed limit indicator. So those are a few exciting things that are happening at Bird. Again, thank you guys for including us this morning, and I'll turn it over to Robert.
Thanks,
Hey,
KAYLA.
thanks, KAYLA. Hey, great information from both Bluebird and Roush. So thank you both for being here today. Real quickly, then we don't want to open it up to questions. One of the things we did when we reconfigured our bus centers integrated them into the rest of our stores here in Texas, we knew we needed to enhance our customer service. We launched a dedicated school bus support center phone line in November. We've got a dedicated person for the service calls in there. His name is Jared Rasmussen. If you call that number and press 2 for service, you will get him during normal business hours, and he can help you with figuring out where you're at in the repair process, or even if you need help scheduling repairs. Also, the great thing about this, on the weekends and after hours, it does roll to our RushCare call center line, and that's monitored 24 hours a day, 7 days a week. So if you do have any issues on an activity trip or something, you can call that line and we can help you get back up and running. One thing we did from a corporate standpoint, we've got a young man who works for us now. He's a dedicated school bus liaison, Craig Orenka, and he's there to work with your dealers, your districts, our dealerships, Bluebird and Roush to help solve problems in the field. Also, from a corporate standpoint, directing technician staffing and training with our service operations team, and that is we're ramping that up as we speak. We've launched 3 new stocking locations in Waco, Pharr, and Lufkin to better meet your inventory needs, and so that it'll be there locally for you when you need those and on the shelf. We will be rolling that out to all of our locations. And finally, we thought it was important. It actually should be 24 locations. Next slide, please. We've got you covered from Abilene to Victoria across the state of Texas. These are your dedicated bus contacts. If you need to reach out to one of our dealerships, this will come to you in the presentation. We'll send a copy to each of you. But those are our bus champions at each of our locations. They're there to help you navigate any needs that you have with us. So with that, I want to open up. We ran a little bit long, but the information was great. So just open it up for questions from anyone. Anyone? We get any questions from the chat? Megan?
Not seeing anything in the chat right now, Robert.
Okay. Well, if there are no questions, anyone? I guess we will let you get to lunch. We're the only thing standing between you and lunch. So I know probably everyone's anxious to get going. So we do appreciate it. Thanks for joining us this morning, and everyone have a great day.
Hey, Robert, we did have one come in.
Okay.
So one just came in, and I think we mentioned it before, but if you don't wanna, or you're muted, you can just type into the Q&A or the chat if you do have any questions you want us to take care of. But the one that I had come in is, what is the fuel mileage? So that's a good question. So for the 7.3 liter, we haven't done any actual fuel economy testing yet. We plan to do some very soon, and we'll share the results with everybody. When we looked at the emissions profile, because we had to do pretty extensive emissions testing, and we of course did that on the 6.8 liter as well. CO2 serves as a pretty good surrogate for efficiency. So CO2 is the dead air coming out of the tailpipe, and it gives you a good idea of how efficient your engine is. Between the 6.8 liter to the 7.3 liter, we saw pretty much a 10 to 15% improvement. So we're hoping, when you're talking about a vehicle that gets 4 to 5 miles per gallon, a 10% improvement, isn't totally earth shattering, right? But it is going in the right direction. So, with our average on a propane being around 4.5, we're hoping the 7.3 liter stays right in that same zone, or is a little bit better, closer to 5 miles per gallon. Same thing on the gasoline. We see, 6-ish miles per gallon, maybe that becomes 6.5. But, all of that's kind of preliminary. It's just some of the indicators that we have from doing the vehicle testing and doing emissions testing. But at the same time, I think we're going in the right direction. We've also gotten some good feedback too from other chassis that are using the 7.3 liter that have launched a little bit earlier, like the E-Series. And we're kind of getting that consistent report back. So we're hoping as good or maybe a little bit better than where we've been. So the right direction. Another one came in from Patrick, which is, it looks like a concern that they're currently getting lower fuel economy. So maybe we could reach out directly, Tom, Robert, KAYLA, to Patrick if possible, and talk to him about maybe possible solutions, best practices, that type of thing to improve, and what type of vehicles they have and everything of that nature. So there are some best practices from a driver's standpoint. There's also ways to configure the vehicle better for the routes that you're on. So we have different rear axle ratios. We have different transmission calibrations. There's a lot of things we can look at to optimize your fuel economy.
Hey, Ryan.
Yes.
Okay, I just want to make sure you're here. This is Tim Gordon. I just want to make sure you're here. One thing I want to remind people of is, and we really didn't address it, but with the fuel pricing going up at the pumps, and I'm sure everybody's aware of it, a school bus that runs an average of 15,000 miles a year, 10 cents at the pump counts for $3,000 a year. So don't let a dime on the market make it look like it's just a dime. It turns into a lot of dollars. Just something to consider.
Absolutely. We're definitely seeing the price at the pumps here in Michigan go up just about every other day they click up. So I'm definitely keeping a good eye on that. Good comment, Tim. We did have another question come in. So this one is, I've had issues with air compressor belts on the 6.8 liter. Is the new 7.3 liter air compressor adjustable tension wise? So I think that refers to, on the 6.8 liter, we had a stretch belt design. And that was part of the third sheave. So on the 7.3 liter, that has all been redesigned. So that air compressor belt is now on a tensioner, and it's now part of the second sheave. So yes, it's a completely different design than what we had on the 6.8 liter.
Good, thanks. Thanks, Ryan.
Absolutely. That is the last one I see there. I'll keep an eye out here. I don't see any in the chat. Perfect.
Okay, well, thank you everyone for attending. We really appreciate it, and thanks to the Roush folks and the Bluebird folks for that great information. So everyone have a great day. Thank you all.
Thank you all.
Thank you.
Thank you.